Good morning, everybody. Let's get down to business. Tomorrow is our quiz number 3, which is about session number 11, 12, and 13, which is advanced planning in supply chains and transport, the introduction to transport management, including the transport infrastructure. Given that we have the quiz tomorrow, I would like to go through the most important slides again, and of course I'm ready to take your questions since this is a live session, and at the moment the number of students participating in this live session is not very high. Of course you lose the chance to ask questions, but I will still go through the most important slides for the quiz number 3. So let's start with a revision of the concept of advanced planning. We use advanced planning in supply chains. And recall that the main learning goals of this lecture were that you should be familiar with the main concepts of planning in general. So what is planning in general? You should be able to understand the characteristics of advanced planning in a supply chain. You know planning tasks in a supply chain, and you are able to classify planning tasks in a supply chain. And for this classification, we use a supply chain planning matrix. I want to highlight again that this lecture is built on the chapter number 4, Supply Chain Management and Advanced Planning, written by Fleischmann, Meyer, and Wagner in the book of Hartmut Stadler et al. And this is available via Moodle. So let's get down to business. First of all, the first goal, know the concepts and be able to explain the concepts of planning. So planning means we prepare making decisions. And in the real world, in the business real world, in the economic real world, there are hundreds of individual decisions that we have to make every day. We are not always fully aware of all these decisions, but there are many, many decisions that we are doing. And of course, the more important the decision, the more it should be prepared. And this preparing a decision is the activity of planning. So what are some of the main components in planning? First of all, when we create a plan, the main task is to think about what are our possible alternatives. What are the different paths we can go in the future? What are our possible options? And once we identify these alternatives, we have to evaluate these alternatives. So how good is each of these alternatives? And we select an alternative. Sometimes we are only interested in selecting the best alternative, and in other cases, it's good enough to select just a good or a feasible alternative. And there are 5 main phases of planning. First of all, we need to understand that we have a planning problem, that we have a problem where we need to make a decision. People do not always recognize this fully, that there is a planning problem to be made. And part of this first step is also analyzing, understanding, dissecting this decision problem. Step number 2, we need to define objectives. So what are the goals in doing this decision? How does a good decision look like? Step number 3 is forecasting future developments. That means we need to have an idea what the future will bring for us. In terms of supply chains, in terms of business, a standard forecast is how much do our customers want to buy in the future? What is the demand of our customers? What is the demand of our customers for certain products? Step number 4 is identify the different activities, the different options that we face. What can we actually do if we want to reach a certain outcome? And evaluate these activities. So we assess these activities, how useful are they for us? And an activity that fulfills all our constraints is called a feasible activity. And we also sometimes call it, depending on the context, a feasible solution or a solution for our decision problem. And in the end, we select out of these feasible activities, we select a good solution. Sometimes we only select the best possible solution. Sometimes it's enough to select a good solution. Maybe there are only 3 solutions, and then we are interested in selecting the best solutions. In other types of problems, there might be 200 solutions, and we are not able to evaluate them, but we know we are not able to fully evaluate them, but we know that some of these solutions are good enough. And then if we select out of the 200 solutions, the 10th best solution, that's still fine. There are 3 main methodologies that we use in planning: forecasting, simulation, and optimization. With forecasting, we try to get a picture of what will happen in the future. With simulation, we build a model of a real-world logistics system. We run this model, and by doing this, we learn more about the behavior of this system. We can see what happens if our demand increases suddenly. For example, we could make a model of an airport and the passenger flows inside this airport. So then we could test what happens if suddenly some planes are cancelled. How will this affect the flow of passengers? What happens if the demand suddenly increases? How will this affect the flow of passengers? So with a simulation model, we learn to understand a real-world system. However, a simulation model does not recommend actual solutions, actual alternatives to us. It helps us to understand the real-world system. On the other hand, an optimization model has constraints that explain how does a feasible solution look like, and we have an objective function that measures how good is a feasible solution. So with the help of the optimization model, we are able to identify good or the best solutions. Okay, through this I can go a little bit quicker. We have the planning horizon, and usually we distinguish between 2 or 3 planning horizons. The planning horizon is the time span during which our decisions are valid. And when we're talking about long-term planning, we usually also talk on the strategic level, and the effects of long-term plans are visible. They create value over a couple of years. The midterm planning is usually a time frame between half a year to 2 years. And what's special, here we start considering seasonal demands. On the long-term planning, we don't care about seasonal demands. it's too highly aggregated to take care of this. And on the short-term planning, we use actual data. Actual data means actual operational data, like actual customer orders. And in contrast, on the mid and long-term planning level, we base these data on forecasts, while short-term planning is usually actual operational data that's in our systems. And the short-term planning is happening on a very high level of detail, while the long-term planning is much, much more aggregated. Now, when we look at planning in supply chains, usually we face many different objectives, many different criteria. Recall in logistics management, we discussed performance measurement approaches, and usually, of course, a company is always interested in the bottom line, in the profit that we generate. But in order to generate, we have to deal with, in order to generate profits, we have to deal with many different objectives. So, for example, we can make our customer happy by increasing our customer service. And by doing this, we would hire, for example, a lot of call center agents that can take the calls of customers immediately, so that they don't need to wait. We could increase our inventory levels so that everything that the customers might order is already on stock and we have very short delivery times. Then we increase the customer service and make the customer happy. But on the other hand, the more inventory levels we have, the more stuff we have, the higher our base cost for our operations. And this will be bad for our profit. So there's always the task of balancing different criteria when we plan in a supply chain. Of course, in a supply chain, we are also dealing with several companies, and every company might have a different direction to go, a different objectives. They are self-interested, and we need to coordinate these objectives. In general, we have a very high number of alternatives that we can choose from. And in order to deal with this huge number of alternatives, we use sophisticated mathematical optimization methods from the domain of operations research. Operations research, we will have a course on operations research in semester number 3 for all our logistics students. But I can tell you already that this is a very important domain of methods in order to deal with this huge number of alternatives. And in every planning, we have to deal with uncertainty. We need to make assumptions about the future. We don't know what will happen in the future. So we need to make some kinds of assumptions. We need to use some forecasting methods in order to get a better idea what might happen in the future. At least that we have some probabilities. And this is important. Therefore, it's important that we have a good statistical knowledge. Of course, the future is uncertain, but this does not mean that we don't need to prepare for possible activities in the future. If we say the future is uncertain, I don't need to prepare at all, then we make a big mistake. If we know the future is uncertain and we have, let's say, 2 or 3 different plans, what we could do in case some events happen, and then this event happened, we are much better prepared. If something else happens, okay, bad luck. But usually already thinking about the future, what happens if, helps you to prepare for it. When you are writing a final exam, you also try to anticipate what might be possible areas of questions, and you prepare for this. And if such an area is in the final exam, then it's good for you. You're prepared for it. If it's not in the final exam, okay, then you'll also learn something, but you could not use it in the final exam. Was there a question?
Mr. Can you explain the first point again?
The several criteria?
Yes.
Yes, so in a supply chain, but not only in a supply chain, it's for a single company, it's a similar case. But if we are dealing with a supply chain consisting of several companies, it just becomes a bigger problem. Yeah? So every company is self-interested and they want to increase their own profits. Yeah? And as you know from logistics management, there are several approaches to measure performance on different levels: operational level, strategical level, society level. And all these criteria that a single company can follow have to be coordinated in a supply chain as well, because we have several companies that may follow these criteria. And not all the criteria, you know, if I'm becoming better in one criteria, I might reduce the quality, the outcome in another criteria, because the criteria are in conflict with each other. And here the example, so I can increase my customer service by hiring more staff, by having higher levels of inventory. Then I will make my customer more happy because I'm able to deliver faster. I'm able to take the calls, the complaints, the orders of the customers quicker. This will be good for my customer, but on the other hand, of course, I have to pay the salaries of the additional staff. I have to deal with the additional costs of having higher levels of inventory. And this, on the other hand, will be negative for my profit. So I need to try to find a good trade-off between these two criteria, making the customer happy, taking care of my bottom line, so that the whole system is working well. And of course, this problem becomes more complicated when I'm in a supply chain that consists of several different companies that all may want something different. And I have to coordinate between these incentives, between these objective criteria.
Mr.
Yeah.
How I can make questions to help me to memorize it or maybe understand it very carefully. This slides like this. It's like I have to memorize it, but maybe I feel it's very hard to me to memorize. And I want to some question that I can it can help me to understand what.
If you just memorize these slides, it will not be very successful for you, at least in the long term. Yeah, you need to start to understand this. And how can you understand it? How can you do more than just memorizing? The first thing is to not rely only on the slides. You need to study the same material from different points of views. And the first option is to also read it from the textbook, which may give you different examples, which may explain the same situation from a different point of view. And then this helps you creating an understanding of what's going on. If you just sit in front of the slides and try to memorize it, this will not help you. You need to be able to explain it in your own words. I also recommend always to from time to time learn in groups with 2 or 3 students and explain the ideas, the concepts to each other, try to clarify things where you're not sure in the group. This will help you preparing for all kinds of courses, not only in this course, of course. The first step is certainly to also have a look at the textbook. And then
Mr. Atul,
you want to
the
go
questions will be multiple choice, or we have to write something, so we can write it will or without wrongs.
Well, you see that you already focus very much on the questions in the quiz. It shows that you are more concerned about the quiz and less concerned about the actual understanding. Yeah, you think about the context only from the quiz point of view, from the grading point of view, and this limits your approach. Yeah, I understand this because at the end of the day you are evaluated by grades in quizzes, etc. Yeah, though I can see where this is coming from, but if you think about all this material only from the quiz point of view, you will not really create a proper understanding. Maybe you even have good grades, but you will not be able to apply this knowledge in the real world later on. And for our quiz, I mean, many questions will be, how to say, closed forms questions like multiple choice, or okay, this for this part of the course there's not so much calculation, but there will not be too many essay questions because we are just too many students. You see, if every student writes 5 pages in the quiz, and then there are 70 students, then I have to grade 350 pages, and I need just a couple of days for only on this grading. Yeah? Also, to be realistic, this will probably not happen. But you should do discussions with your friends to practice this, because if you are forced to explain a concept, an idea, a method to your friends, you think in a different way about it. You start thinking in a different way about it, and you become more independent of the slides. And in the end, this improves your learning skills drastically. Okay. So one approach of planning that is very common in most companies is rolling horizon planning. Maybe you already used the same concept when you prepared for your final exams. Let's say you have 4 exams to prepare for, and a bad approach is to learn only for the first exam. You focus your time on the contents of the first exam, and then once the first exam is over, you start preparing for the second exam, and the second exam is over, you start preparing for exam number 3. So this is probably a bad approach. You need to learn every day different topics. Yeah? Then this makes your brain more at ease, and you spend more time, more days, not more time, but you learn a topic over a longer period of time. If you only prepare on 1 or 2 days before the topic, it's almost like wasting your time, and it's very stressful. So you need to spread out the learning over a longer period of time. And let's say you prepare for these 4 exams. You plan for the next 4 weeks on which day you want to prepare which chapter of which course, and then you start learning. And after the end of week 1, you realize, oh, for this course, I made much more progress. I was well prepared during the semester, and I don't need so much time to refresh my memory. I understand it very well, so I have a much bigger progress than planned. But for another course, I'm way behind. Then after the end of the week, you update your learning plan for the remaining 3 weeks until the exams are there. And if you do something like this, this is already a rolling horizon planning. You plan for a couple of periods, in this example on the slide for 12 periods. And after the end of the first period, you see what actually happened, what is the actual progress, what are the actual developments. You freeze everything that happened during the first period, and you start updating, revising, and planning for the next 12 periods. So once January is over, you see what has happened in January and how does this affect the other 11 months, and you make a new plan for the next 12 months. So you always look ahead for 12 months, and every month you update and revise your plan. This is called rolling horizon planning, and this is a very common planning approach in the real world. Now, these were the foundations, the concepts, of planning activities in general. You can apply this to supply chains, of course. You can apply this in the logistics world. You can apply this to the business world, and you can apply it to your private life in any possible way. So these were the main concepts of planning. Now let's do the switch to the advanced planning systems. So we have here a kind of advanced method of planning, and this is now focused very much on planning within supply chains. When you're talking about advanced planning systems, we are always talking about supply chains. And there are 3 main characteristics of advanced planning systems, in addition to the general concepts of planning. Though, first of all, we try to achieve an integration of our planning. We integrate plans of several members of the supply chain, at least from our tier 1 suppliers to our customers. Of course, we can also try to include tier 2, tier 3 suppliers and customer of our customers. Then the plan would be even more complicated. But the main point is, we are not only looking as a company in a supply chain, we are not only looking at our own situation. We try to include our suppliers in making the plans, and we try to include the plans of our customers in our own planning. So this integration is the first main characteristic. The second main characteristic is that we use software-based systematic optimization methods based on sophisticated methods from simulation and optimization. Though that means we have a true optimization by using optimization methods from Mars. We are not just discussing in a meeting what we should do and what people think might be the best, and then the guy who shouts the loudest is right. No, we apply systematic methods designed for planning, which usually always includes optimization software. That means our planning problems are very well formulated. So we know about the exact objectives, we know about the exact constraints, etc. So we have a formal definition of our planning problems, and we have formal methods to solve these planning problems. And the third criterion is that we apply a hierarchical planning approach. So there are two other planning approaches: simultaneous planning and sequential planning. In sequential planning, we divide the whole planning problem in several tasks. And then we start with planning one task independently of all the other tasks. Once this is done, we use the solution of this task and solve the next task. Yeah? If we realize the solution of the next task is not very good because we made something wrong in the first task, we don't integrate this in our planning approach. We don't use this knowledge to resolve the first task again. We just solve a defined sequence of planning system problems. So for example, in geotech, we are supposed to create a teaching plan for the next semester. For doing this, I have to assign professors to courses. I have to assign courses to rooms. I have to take into account when are the life skill courses, when are the shared courses between logistics and IBSM, what rooms are available. And now I could solve this in a sequential way. The first step, I assign every professor to a course. This would be the first planning problem I solve. Once I know which professor will teach which course, I have a look at the available rooms. Now, when I realize that I do not have enough big rooms available, I will not go back to the first problem and, for example, change it in a way that I have more sections of a course in order to require a smaller number of big rooms. So I solve the first problem and I move on to the second problem. On the other hand, in a simultaneous planning approach, I try to solve all the planning tasks at the same time. So the assignment of professors to courses is solved together with the assignment of rooms to professors and courses, so that both problems are interconnected. So for the scheduling problem, this might work well at the end. But if we go to very big supply chains with hundreds of companies, hundreds of suppliers involved in these supply chains, like an automotive supply chain, then this requires too much data. This requires too much interaction between the different member companies, that the planning tasks will be too complicated. And in hierarchical planning, now the difference is that I have also my big planning problem structured in smaller planning tasks, smaller planning tasks for the whole supply chain. And I start solving a higher level problem. I take the solution of this higher level problem and solve a lower level problem. However, now in contrast to sequential planning, if I realize the lower level problem has a somewhat bad outcome, I can use this information and go back to the higher level problem and solve these tasks again by applying different objective functions or different constraints. Though there's an information exchange between the planning tasks in the hierarchical planning system. So advanced planning, we have an integration of planning across the whole supply chain. We use formal optimization problems and formal optimization software, and we follow a hierarchical planning approach. On this slide, you see a hierarchy of the planning tasks. And again, we use our long-term, mid-term, and short-term planning tasks. And you see the information flows between the different planning levels. Yeah? So this is a special about the hierarchical planning, that although we start with a long-term plan from the top, and once this is done, we go to the midterm level. We still can get information back from the midterm level to the long-term planning if there's a serious problem. Of course, the main flow is top down from the top to the bottom, but it's still possible to get a feedback. Yeah? This is a special about the hierarchical planning. And there may also be an information flow on the same level, yeah, on the horizontal level between the different planning tasks. This is special about the hierarchical planning. If it would be sequential, then we only have a flow from the top to the bottom, and there would be no horizontal flows. This is important. Of course, the data, the planning data that we use on the highest level, on the long-term problem, is highly aggregated, while on the short-term level, it's much more detailed. And the coordination between the different plans of these different planning tasks, we have here 1, 2, 3, 4, 5, 6, 7 main planning tasks. They are coordinated by these information flows. This is how the plans are coordinated. In sequential planning, there would be only there would be no feedback. Now, this is a very important picture, and as you can see, this is explained in the textbook in a very high detail. It's the same structure that we had before in the hierarchical planning matrix. And now we added different processes in a supply chain: the procurement process, the production process, and the distribution process, and finally the sales process. And inside this matrix, now we added many different planning tasks. So for example, the physical planning of the physical distribution structure is a part of the distribution process in our supply chain, and it's a long-term planning task. What does this include? This may include the number of warehouses and the location of the warehouses that we want to use. For each of these points in this picture, you see on the coming slides, on the next slides, an explanation. So here we have the physical the product program and strategic sales as the first step, and the second step, the second problem, physical distribution structure, number, size, and locations of warehouses, cross-docking points, and transportation links. Plant location and production system, materials program, and supplier selection. Though this goes through this matrix from the right to the left, starting with the long-term tasks, then we have the mid-term tasks, again from the right to the left, and we have the short-term tasks at the end. Why do I start with explaining from the right to the left? Because a main trigger, a main way to coordinate the supply chain is coming from the sales side. So first we have to get an idea how big, how much will be our sales, what will we sell, what is the demand of our customers, what types of products might they like. And if we have an idea about this, we can decide what are the products that we will offer. In which regions will we offer our product? Will we offer the product only in Oman? Will we offer the product in the GCC? Will we offer the product in the GCC and some Asian countries? Will we offer the product in Oman and some African countries? This is a strategic sales decision. And once we have this decision, then we can think about our distribution structure. If we decide to sell the product in the GCC, then of course we need to have partners or warehouses in the GCC and not in other countries. Then the same, when we know where our distribution structure is, where we want to sell, we can think about where to produce and what types of production systems we see. So each of these points in this graphic is of course explained in the textbook, which you should have a look at. And there are examples given on these slides. So for example, for materials program and supplier selection, we can use the ABC analysis that you know from logistics management. Materials program, supplier selections, cooperations. So for example, for our A items, for our A products, we use a different supplier or we produce it in-house, and for the B and C products, we use different suppliers to get these products. The same structure then on the midterm planning tasks. I will not go through all these again, but I just want to highlight how to read this table, where to find the information in the slides, and how it is supported by the textbook. Now let's have a look at one short-term planning tasks. The short-term personal planning, order materials, staff on shop floor with required knowledge and capabilities, staff scheduling, overtime, labor contracts. So if we are here, the short-term procurement planning, short-term production planning, we have to decide, do we need to ask our staff to do overtime? Which staff should be used on which machine? What are the skills of the staff to do this task? What is the availability of the staff? Maybe some are on holidays, others are sick. Yeah? These are very operational short-term plans based on the actual production requests that we have. On the higher level, the planning is based on forecast, and usually we have a big grouping of products. We plan according to product groups, not individual products that we want to produce. So this matrix is quite important. And then finally, one important job in a supply chain is that we always have to do a coordination of our tasks and an integration of the activities. So in this supply chain planning matrix, the coordination mainly happens through the flow of information. Which planning module knows what, when. And the horizontal information flow, is mainly upstream. That means from the sales through the distribution over production to the procurement. So it's coming from the customer demand. This is the main flow of the main direction of the horizontal information flow. The supply chain is driven by the customer in most cases. We have also something that is called sales and operations planning. This is usually a management meeting once a month, for example, where we have an information exchange between the sales-oriented part of the company, like marketing, sales, and the operations-oriented functional part, so the production side of the companies. Because it does not make sense that sales is planning for something, like we want to attract new customers in new countries, and then the production side says, oh, we don't have enough capacity, or it is difficult to deliver to this country, and that's not possible. So the plans need to be aligned, that the sales is not selling something that's not available for production. And on the other hand, production is interested in producing the things cost-efficient way. And this also needs to be aligned with the sales plan. And as I already highlighted, between all the planning modules, there's an information exchange possible. And this will increase the performance of the supply chain significantly. Please pay attention. Here in the, I go back to the matrix. Here in the drawing, we only have the arrows that reflect information flows between neighboring planning tasks. However, in reality, it's also possible that there's an information exchange between this planning tasks and the procurement side. So there's also an information exchange between planning tasks that are not always neighbors. So for example, from the production midterm, there could be a feedback to the long-term procurement side. These are the main information exchange as shown here by the arrows, but basically between every planning module can be an information exchange to all other planning modules if this is reasonable. And for the vertical flow, from the top to the bottom or from the bottom to the top, both directions are possible because we are in hierarchical planning. Of course, the main direction is somehow from the top, from the long term to the short term. But if we make a plan and then we realize on a lower level, oh, we don't even have enough capacity, then we can give this as a feedback to the higher level in order to update and change the plans. Here we have a small case study, also from the textbook. I will not ask about this case study in the quiz. However, this is something that you can read in order to increase your understanding of the topic. So this is a different angle on the product, on the contents of these slides, and this is something that you can study to get a different point of view, to question your understanding and to learn better. So it's not just here for fun. although I will not ask about this case study in the quiz, but it helps you to improve your understanding of the materials. So in this slide set, we discussed the foundations and the main concepts of planning. You also got an understanding of the main characteristics of advanced planning. What does it mean when we're talking about advanced planning? True optimization, integrated planning. These were two very big ideas, and hierarchical planning. We discussed this supply chain matrix, which clusters the planning tasks long-term, mid-term, short-term, and from the procurement to the production, to the distribution, to the sales. And now we can put many different planning tasks into this matrix and explain these planning tasks. And this matrix also shows you the hierarchy of the planning tasks and the information exchange between the planning tasks. And the information exchange is the main driver of the coordination of the different plans. Now let's switch gears from the advanced planning system to the transport modes and the transport infrastructure. I think the advanced planning system is a very it's a more difficult concept than the transport modes and the transport infrastructure, and this is why I wanted to repeat it again today, that you are more aware that it's not just about memorizing the slides, and that it's a quite complicated idea that is discussed there. And this will lay all the foundations of other courses like supply chain management. Now let's go to the introduction of transport management and the different transport modes. For this lecture, you should understand the nature and characteristics of a transport chain, and you should be able to identify transport chains in the real world and explain these concepts to other students. And then you should know about the different modes of transport, and you should be able to explain the main characteristics, advantages and disadvantages of these 6 transport modes. Again, this is done also in the textbook. The Transport Systems and Logistics Services chapter discuss all the advantages and disadvantages of these different transport modes. So have a look at these chapters too. Let's start with a transport chain. So a transport chain gives you all the points, the stations, and the different links between these stations that a good passes from the origin to the destination. So we go from a source to a sink, or from place of dispatch to the receiving point. Let's say we order some laptops. We are a company that is selling laptops in Oman. And then we don't produce the laptops ourselves, but we order these laptops from a factory in China. And then the point of origin, the source, will be this factory in China, and the receiving point will be our shop in the mall where we want to sell the laptops to the final customers. And now everything that happens between the source and the sink is part of the transport chain. And in general, transport chains follow these three main phases: the pre-carriage phase, the main carriage phase, and the on-carriage phase. And the pre-carriage phase and the main carriage phase are connected by a transshipment point. And the same here for main carriage to on carriage. Yeah. Though in this transshipment point, we change the mode of, not necessarily the mode of transportation, but we deal with our goods in some way. Yeah. Sometimes we store it, or we wait for another truck, and sometimes we also change the mode of transportation. We collect the goods from the sender and bring it to a transshipment point, which might be, for example, a port. We collect the goods from the factory in China and bring it to a port. Then in this port, the goods are maybe stored for a couple of days until a ship arrives, and we transship the laptops onto the ship, and the ship travels to maybe Port Sohar, maybe to Dubai, until it reaches the next transshipment point, which will then be again a port. And here we load the laptops on another truck, and this truck goes to our shop at the end of the day. Of course, there might be several other warehouses involved in this link, but this is the main structure. What is important about this structure is here the main carriage. We try to bundle a lot of products on our main carriage. That means for the main carriage, we usually use a very big vehicle, like a very big ship, very big plane, very big truck, and we try to use the full capacity of this vehicle, though that the unit cost of transporting the goods over this long distance are very small, because we can use economies of scale. Though we have this transport chain, this is beneficial because we can use economies of scale, which makes the long distance transport very, very cheap. So usually the most transportation costs happen on the on-carriage and pre-carriage level. And the main carriage level is usually, although it's the longest distance, it's usually the cheapest in the whole transport chain. This is why the structure is important to know. Now we have some terminology that you need to be aware of. We have combined transport. So we move goods through a transport chain in one and the same loading unit. What is an example of combined transport? We have our laptops in a container, and we use the same container from the factory to the ports, to our receiving warehouse, to the shop. We don't change the loading unit. And of course, we never handle the laptops themselves in the port. We always use the loading unit. We put the container up and down on our ships, but we don't touch the individual laptops. They are in the container. Another term is intermodal transport. Intermodal means use different modes of transport. So for example, we use in one transport chain street transport, and water transport, or street transport and air transport. What are possible loading units? Of course, today the container is the most important loading units, but we also have other loading units. For example, the vehicle itself. When we transport cars or trucks, because someone sells cars or trucks, then the loading unit will be the vehicle itself. And for this, we have something like roll-on, roll-off shifts. And our laptop example from the factory in China to the shop in Muscat is an example of intermodal transport. So we collect the container with laptops via truck. We bring it to the port, which is the transshipment point. We load the container on a ship to use economies of scale, because we do not only transport one container with the ship, but thousands of containers. And we use the ship to sail to our discharging port, which is another transshipment point. And from there, we distribute the container again via truck to the receiver. So we have two modes of transport. We have combined transport. We only touch the container, and we change. Yeah, we have intermodal because we change the mode of transport. Now, there are usually 5 or 6 modes of transport distinguished in the literature. The most important for most countries is the road freight transport. We have rail freight transport. This is about 10% in Europe of the freight is transported by a rail. In Oman, we don't have rail transport, though it's we don't need to take care of it inside Oman. We have the sea freight transport, which is very important for the world economy. We have the inland waterway transport, air freight, and pipeline transport. Pipeline can, of course, transport not only oil and gas, but also water or other chemicals. Now, how do we measure the performance of a transport mode? A popular measure is ton kilometers. So this measure, ton kilometers, measures over what distance do we transport what weight of goods. So if we transport 5 tons of a good over 20 kilometers via truck and over 150 kilometers via train, then our ton kilometer performance measure of the transport we did is 5 tons times 20 kilometers plus 5 tons times 150 kilometers is 850 kilometers. Of course, this focuses very much on the weight of the goods that are transported. So if we have electronic goods that are very light, but many may be very valuable, then this is not very well reflected in this measure. But it's just one measure, ton kilometer, that you should understand. Now, if we look at the freight transport in the European Union as just one example, then I have here the percentage as measured in ton kilometers of the transport performance of 5 transport modes. So here they exclude the pipeline, although pipeline is of course also very important in the European Union. And you see, okay, this graph focuses on the transport within the European Union. So if we are looking at air and maritime transport, we look only in this statistics on that is here shown on the screen. We only look at what is transported within the European Union. For example, from maritime transport, what is transported from Spain to Denmark, for example. This statistics does not include what is transported from Oman to Spain, because this is not within the European Union. So this is the data that is shown here, and you clearly see that road transport is the most important transport mode in the European Union based on the measured ton kilometers. Maritime is the second most important. Then we have rail, and maybe surprisingly for you, air transport is only 0.1% of the whole transport performance. So why is this such a small number? So maybe there are two effects to explain this. I believe, though, the first one is maybe air transport within the European Union is not very popular. Maybe air transport is more popular if we transport goods from China or from the US to the European Union, which is not in this statistics. This might be one factor. And the other factor is when we use air transport is quite expensive compared to road and ship transport. When we use air transport, we usually transport very expensive goods, and often these very expensive goods have a very low weight. So if I get my iPhones from the factory, then the iPhones are not very, the weight is very small. If I transport grain or iron ore by a ship, they have a very high weight. So this is why you need to understand the implications of this measure ton kilometers. And of course, when we know which mode of transport is most important, this is where we should spend a lot of attention. Now we can compare these modes of transport according to several criteria. These criteria are defined in our textbook. And here the mentioned criteria are mass transport capacity. So how suitable is a mode of transport for mass transportation? The speediness, how quick is the mode of transport to fulfill the transport service. Though a plane, air transport, has very high speed. Ship is very slow compared to a train. We have the criteria of network forming capability. What types of networks are required? So in order to offer road transportation, we need a network of roads. If we don't have a connection to one of our factories via roads, then we cannot use this mode of transport. On the other hand, building roads and having roads is very common. On the other hand, if you are using a rail transportation, this is much more difficult to form a railway network. You have to invest in this railway network. It's much less flexible than a road network, etc. How predictable is the mode of transport? Will it be on time most of the time or not? How flexible are the schedules? So with a truck on road transport, you're very flexible. However, if you use a plane or a train, you need to follow the given schedules by the companies. Otherwise, you will not have any chance of being successful. Spatial flexibility, which areas can we reach with this mode of transport? How safe is this mode of transport? And what is the environmental impact? So let me show you some hints in the textbook. If we jump to chapter 5 of the textbook, you find all of this explained. Is it coming? Here, chapter 5 of the textbook. We have the different modes of transport, and here are all the criteria explained how we can compare these modes of transport. And then for each mode of transport, here we start with road freight transport. We have such a table, table 5.1, where the main characteristics are reviewed of a mode of transport. And this continues then for rail freight transport. Here was the main characteristics in this table. Sea freight transport, again, the main characteristics. Relative low transport speed, so you need much more time. The safety is very high. It's quite cheap, in particular for long distance. You can transport almost every type of goods, especially useful for long haul and intercontinental transport, for example, from Asia to Europe, and transport of large volumes of goods possible or usual. So you can, for example, make an oil tanker full of oil and transport it over the long distance. You would not do this with a plane, or you would not use for the same long distance oil tanker on the road to transport the same amount, because this would be much more expensive. Though again, I want to show you how to incorporate the textbooks in your learning, and that you are not only depending on the discussed slides. So we discuss here all the different modes of transport, and here again the highlight to the different explanations in the textbook. Now finally, let's have a look at the last session about the transport infrastructure. Here you should be able to distinguish between different types of infrastructure, and you should know some of the principles of the different transshipment terminals that are out there. Again, the link to the textbook, which is available via Moodle, and we start with the definition of the term infrastructure. Here it's important to understand that we can distinguish between macroeconomic infrastructure on the one hand and microeconomic infrastructure on the other hand. Though from the macroeconomic level, we have transport infrastructure like roads, airport. We have the available information systems. These are usually IT systems that the companies uses or that the government uses, for example, for tax, import, export management, customs. And we also include under this economic infrastructure the telecommunication infrastructure, for example, fiber internet, mobile internet accessibility, If this is not available, then many of our modern information systems will not work to their full potential. On the other hand, we have also a social infrastructure. That means we have to think about infrastructure that provides education. For example, geotech is providing education in logistics management, in supply chain management. Though this is also part of the logistical infrastructure, because only having roads, only having IT systems, but not the qualified people to make something with this will not be helpful. On the other hand, if we go on the lower level, on the microeconomic level, on the level of the individual company, we have technical and structural properties. So if we look at our airport, how many terminals are there? What is the capacity in terms of freight and people transportation? What are the opening times of this airport, 24 hours a day or only during the daytime? What are the specific warehouses? How are they equipped? Can we use them for refrigerated goods or dangerous goods, chemical goods? What is the equipment inside the warehouses? Do we have an automated conveyor belt system? Are we using robots? Is it operated by manual labor? These are more on the microeconomic level. Now, when we go to transshipment facilities, in the transshipment points of the transport chain, there are different transshipment facilities. One example of a transshipment facility that I gave you was the seaport. Of course, an airport is also a transshipment facility. A transshipment facility can also be a simple warehouse. And in such a transshipment terminal or transshipment site, the following activities are happening. We have a loading of goods, unloading of goods from one means of transport. Usually we have always a sorting of goods. There needs to be some sortation. And often, but not always, we also store goods. If we do not store the goods, though if the goods are loaded from one means of transport to another, then we speak of a cross-docking site. Many transshipment facilities, we have different modes of transport that converge. For example, in the seaport, we can have road transport converging to sea transport. But of course, it's also possible that containers are loaded from one ship to another ship. So it's not necessary that the mode of transport is changing, but often we have several, in a transshipment facility, several modes of transport changing. Now we have some characteristics of airport terminals. These are special transshipment sites on the land side and the air side. I gave you examples about Frankfurt Airport, which is of course very, very similar to Muscat Airport. We see here the air side with the different gates where the passengers have access to the planes. We have the taxiways where the maneuvering of the planes happens. And we have the takeoff and landing lanes where the planes start. Of course, there are also other infrastructure related issues at an airport. For example, here we have some petrol tanks to fuel the planes. We have also a fire station in case of some emergency, that the airport can deal with it as fast as possible, and we are not dependent on the public fire stations. So this is all part of the infrastructure of an airport. And then there are different roles of airports, in particular when we are talking about the hub airports. This is also something that is happening in the transport chain, when we have several smaller regional feeder airports. They bring passengers to the big hub airports, and then one big hub airport from one region provides the passengers via plane in a big aircraft to an international hub airport in a different region. For example, from Dubai to China. So the regional airport would then be Muscat Airport, other airports in the region that bring all the passengers to Dubai. And from Dubai, we use a very big aircraft to transport the passengers to, for example, Beijing. And again, we have the idea of the transport chain. On the long distance, we can use economies of scale to reduce the cost per kilometer that a passenger travels. And the regional airports' task is to feed passenger to the hub airports. Sometimes we also have dedicated cargo airports. They are often far away from the lively cities. And what is very important for these cargo airports, that there are no bans on night flights, because for cargo, of course, it doesn't matter when the start and landing times are. They can start and land and use the planes all around the clock. And these bans on night flights are common in European airports. For example, the big hub airports in Europe, they have a very limited number of time slots where planes can start and land in the night, in order to protect the people living around the airports from the noise. Now here we have some more characteristics of seaports and inland ports. Maybe let me only highlight the idea of the hinterland. The hinterland are all the territories that exchange goods with the port. It may be far away from one port, though it's not a defined area around a port like 50 kilometers. It's just the territory that exchanges goods, that uses this one port to transport goods. For example, if from the Muscat area we use the port Sohar to ship our goods, then Muscat would be considered as the hinterland of Port Sohar. If we use Port Dokkum from Muscat and transport our goods to Port Dokkum, then Muscat would also be considered as the hinterland of Dokkum Port. This Port Duisport in West Europe is one nice example for an inland water port that is very important transshipment point in terms of converging rail transport, water transport, and road transport. Though all these three modes of transport are converging in this intermodal hub in Duisport, and it enables the transport from containers that arrive via Rotterdam via ship and continue via the inland water, some rivers in Germany and the Netherlands. But it also enables the transport of goods on the train tracks from Duisburg through Russia until China. So you can reach from Duisburg in West Europe, you can reach China with your goods through this transshipment hub, which makes it very, very important for global trade. We discussed different terminals in a seaport, terminals for containers, terminals for general cargo, for liquid goods, bulk goods, and roll-on, roll-off terminals. Roll-on, roll-off terminals are for vehicles that move on the ship themselves. For example, if you ship cars. And again, I want to highlight that we also discussed freight villages and logistics parks, and that your job is to read about this in the textbook. It's one of the chapters recommended in the textbooks, and don't ignore this. There will be also at least one question on freight villages in tomorrow's quiz. Okay, I gave you an updated, a small revision on advanced planning, transport modes, and transport infrastructure. We did not meet for these contents in the classroom. I did not receive too many questions via Teams on this. I think the question in the beginning by one of you was also very interesting on how to prepare for these types of topics without just memorizing everything. And that's a big challenge that you have to overcome in your way of learning, in the way you prepare yourself for these concepts, which are more of a theoretical nature. Of course, you always find real-world examples, so it's not a purely theoretical discussion. It's emphasized by many real-world situations, real-world problems, real-world challenges. And therefore, to become a good logistics student, it's not only about preparing for tomorrow's quiz, but it's about reading logistics magazines, reading business newspapers every day, being interested in what's going on around you, doing internships at logistics-related companies, so that you get a better insight into how business works and how the world around you works. I wish you the best of luck for tomorrow's quiz. And yeah, the mode of the quiz will be like the other quizzes. It will be offered via Moodle, but on campus in Geotech. Good luck for the quiz and see you soon.